We are working on Etch-a-Sketch Reflections. So to review, to reflect a point P around a line L, so here's P, and here's our line L. So we're going to draw a line through P that is perpendicular to L, so here is our perpendicular line. Then we're going to measure from P to L along the perpendicular line. So we're moving over a distance of D, and then we're going to keep measuring the same amount to the new image. So we're moving over another distance of D to P prime, which is our reflected point. So now our EAS reflections isometries, that's the question we're being asked. Well, we're going to start with this. So the line, we're given the line y equals 1/2 x and these two base points, 0, 0 and 0, 5. So our first step is to find the line that is perpendicular to y equals 1/2 x, and this needs to go through the point 0, 5 because this is our point that we are reflecting. So we need to find the opposite reciprocal of this and make sure that it goes through 0, 5. So this would be y equals negative 2x because that's the opposite reciprocal of 1/2 x, and then because we need a y-intercept, that's going to be 5. So y equals negative 2x plus 5. So to find the intersection of y equals 1/2 x and y equals negative 2x plus 5, we need to set them equal to each other and solve for x. So this is going to help us find this point. So by setting them equal to each other, 1/2 x equals negative 2x plus 5. So to get rid of this fraction, we're going to multiply the whole equation by 2. So that gives us x equals negative 4x plus 10. We're going to move over this negative 4x, so we're given 5x equals 10, and divide by 5, which gives us x equals 2. So this is now our x coordinate for this point right here. So now we can plug in 2 into the original equation. So y equals 1/2 times 2, which gives us 1. So that gives us our y coordinate for this point. So the intersection of y equals 1/2 x and y equals negative 2x plus 5 occurs at the point 2, 1. So now we need to move along the perpendicular line the distance of d. So to get from 0, 5 to 2, 1, we moved a distance of d. And so, to get from 0 to 2, looking at our x-coordinates, we moved 2 units to the right. To get from 5 to 1, looking at the y-coordinates, we moved down 4 units. So we're going to do the same thing as we move along the perpendicular line to get our reflected point. So we need to go right 2 units, so we're going to move from 2 to 4. And we need to move down 4 units, so we're going to move from 1 to negative 3. So this means our reflected point will occur at 4, negative 3. So now we need to figure out if distance was maintained during this reflection. So we're going to find the distance from 0, 0 to 0, 5 and see if it's the same distance as from 0, 0 to 4, negative 3. So to get from 0, 0 to 0, 5, we moved up 5 units, and we did not move over 0 units to either the right or the left. So we add 5 plus 0, which gives us a total distance of 5. To move from 0, 0 to 4, negative 3, we moved down 3 units, and we moved over 4 units. So we add 3 plus 4, which gives us 7. And because 5 does not equal 7, this shows that this EAS reflection did not maintain distance. So this proves that EAS reflections are not always isometries.